Hey everybody, back to the library here. All these books behind me are full of electrical engineering things that I work on daily. Of course, I'm kidding. But anyway, let's start chapter 10. Chapter 10 is called Practical Transformers. And what we're going to do is we're going to take the ideas that we developed in chapter 9 on the ideal transformer, and we're going to look at that from a perspective of, practical applications. Because what we tried to do in chapter 9 was to model this ideal transformer. And so let's look at the differences between what we studied in chapter 9 and what we're going to look at in chapter 10, and try to reconcile the two. And the reason we're doing this, and especially when we get into higher voltages, higher currents, higher power transformers, the practical aspects of that are very important. Okay, so here's some notes that I made about chapter 10, and so that you can look at these and think about them as we're talking about them. Like I said, in chapter 9, we looked at an ideal transformer. We looked at its basic properties, but real world transformers are not ideal. And what we're going to find out is what makes them not ideal. Well, first off, the windings have resistance, and that has to be taken into consideration. Resistance is going to change the whole profile of the transformer, and so we want to reconstruct this as a practical transformer and add resistance. The next thing he mentions is that the core is not infinitely permeable. What we're saying there is that cores become saturated, and increasing current at some point does not have the desired effect of producing the flux. So at some point, the cores become infinitely permeable, and we want to be able to account for that, make sure that we operate within certain parameters. And then the next thing there that's important is that the flux produced by the primary is not perfectly coupled to the secondary side of the transformer. So there is what we would call leakage flux, this magnetic flux that is not used in this transformation process that we're going through. And then let's see, what else we got? The final thing that he mentions are the eddy currents and hysteresis losses. Now, eddy currents are pretty easy to understand. Eddy currents occur within materials that are exposed to magnetic fields. And these currents, they just flow in the material, this ferromagnetic material. Hysteresis, I am going to include a video that explains hysteresis. But the hysteresis is this effect that, if you want to think of it in one particular way, you can take ferromagnetic material and you can do certain things to it. For one, wrapping a coil of wire around it and running current through that wire, and you can permanently magnetize material. And so, if you think about hysteresis sort of in those terms, that's what you're looking at. Now, depending upon the direction of the current, you can change the magnetic pole within the material, and there's this lagging effect that occurs. So anyway, I'm going to post a secondary little video for you, and let you make sure that you're clear on what hysteresis is, in case you missed that in your circuit analysis courses. And so, how are we going to approach this practical transformer? Well, what we want to do is what we're going to do. Our model for our practical transformer will include our ideal transformer from chapter 9. Okay, and we worked with that. And then all we're going to do is we're going to add resistances and reactances to this ideal model, and that will allow us to create this practical transformer. And the reason we want to do that, it helps us to explore things like voltage regulation, parallel connection of transformers. And we're also going to utilize this thing called per units that, goes all the way back to chapter 1. And hope you'll see some really practical benefits from using this.